Hello everyone, welcome to our exploration of Command and Query Responsibility Segregation or CQRS design pattern. As designers, we always seek well-established and elegant solutions to common problems. Cloud design patterns are those elegant solutions for the cloud, instantly enhancing your applications with proven methods for scalability, security, and cost efficiency. In this video, we will discuss a problem, present the design pattern solution, and implement it in a real-life scenario. Whether you're a developer, an architect, or just someone curious to know about this design pattern, this video will provide you with valuable insights. My name is Madhur. Let's get started. Let's begin by setting the context and understanding the problem where you can apply this design pattern. In traditional architectures, the same data model is used to query and update a database. That's simple and works well for basic CRUD operations. But when dealing with more complicated applications, this approach might not be suitable and can result in performance issues. For example, on the read side, the application may perform many different queries to get information for a single screen, resulting in complicated object mapping. On the write side, the model may implement complex validation and business logic. Hence, read and write workloads are often asymmetrical with very different performance and scale requirements. Now let's see how CQRS design pattern can solve this problem. CQRS separates read and write into different models using commands to update data and queries to read data. You can physically separate the read data from the write data for greater isolation. In that case, the read database can use its own data schema that is optimized for queries. For example, it can store a materialized view of the data to avoid complex joins or complex ORM mappings. It might even use a different type of data store. For example, the write database might be a relational, while the read database can be a document database. If separate read and write databases are used, they must be kept in sync. Typically, this is accomplished by having the write model publish an event whenever it updates the database. The benefits of CQRS include independent scaling. CQRS allows read and write workloads to scale independently and may result in fewer lock contentions. Secondly, it enhances security. It's easier to ensure that only the right domain entities perform writes on the data. Another benefit is it results in simpler queries. By aligning the models in the read database to actual business requirements, the application can avoid complex joins when querying. Some challenges of implementing this pattern include: Number 1. Complexity. The concept behind CQRS is simple, but it can lead to more complex application design. Therefore, it should be implemented in areas where it will give higher returns. Second challenge is around eventual consistency. If you separate the read and write databases, the read data may be stale. The read model store must be updated to reflect changes to the write model store, and it can be difficult to detect when a user has issued a request based on the stale read data. Third challenge is the reduced automation through ORM tools. Code cannot be automatically generated from a database schema using scaffolding mechanisms such as ORM tools. However, you can build your customization on top of the generated code. This pattern isn't recommended when the business rules are simple, and a simple CRUD-style user interface and data access operations are sufficient. Now let's look at a scenario where we can apply this pattern. Our e-commerce application, which is built using a traditional monolithic architecture, is experiencing performance issues as it scales. The application uses a single database to handle read and write operations, resulting in contention and bottlenecks, especially during high traffic periods. As the user base grows and the volume of transactions increases, the application struggles to maintain acceptable response times for both browsing products and processing orders. To address the performance issues, we should refactor the e-commerce application using the CQRS pattern. This involves splitting the application into separate read and write sides, each optimized for its respective workloads. The command side is responsible for handling write operations such as creating orders, updating inventory, and processing payments. The query side can focus on optimizing data retrieval for browsing products, searching, and filtering. To improve read performance, we can introduce read replicas or implement caching mechanisms instead of querying the transactional database directly. We can denormalize data structures where necessary to optimize for read-heavy workloads, pre-computing aggregations, or generating materialized view to speed up queries. By implementing CQRS, the application provides a more responsive and scalable user experience. The system's modular architecture also enables the development team to iterate and deploy new features more quickly, further enhancing the platform's competitiveness in the market. If you found this video insightful, do share, like, and subscribe. Until next time, stay curious, stay data-driven.